Hello, Madam Naomi here again. Physics, we're going to continue from where we had left. So in our today's episode, of course, this is physics. Yeah. So you remember we had begun the electric charge. We had mentioned two types of charges, that's positive and negative charges. We had looked at the structure of an atom, subatoms, protons, neutrons and electrons, and we had mentioned the charges. The protons are positively charged and electrons are negatively charged, and the neutrons are neutral. And we say the overall charge of an atom is what? Is neutral, because the number of positive and negative atoms, particles are the same. Yes, so, and I told you we were supposed to look at 4 experiments. Of course, we're looking at charging materials, that is insulators, by what? By friction. Yeah, by rubbing. That's friction. Yes, so I told you we have around 4 experiments to look at here. We had looked at the first experiment. We had used the rod and what? And a piece of cloth. And for today, the second experiment we're going to look at here, this is a very common experiment. I'm sure you've done it before. Yeah, it's a very common one. But now, you know, we shouldn't ignore any experiment here, because at the end of the day, you will need to explain. Yes, so, of course, the topic is still under electric charge. Electric charge, that is static electricity. Static electricity. Yes. So, the second experiment we're going to look here is a ruler and some pieces of paper. Ruler and some small pieces of paper. Small pieces of paper. Yeah, this one is a very simple experiment. I wish I could get a ruler and some pieces of paper, but I'm sorry I couldn't remember to carry them. Yeah, it's a very simple one. You can even do it as I explained. Yeah, we have a ruler here. We have a ruler here. Of course, I might not be perfect at demarcating it. Yeah, but it has around 5 divisions. Yeah, so that's our ruler here. Now, this ruler, we're going to rub the ruler. We're going to rub the ruler. We're going to rub this ruler either against your hair or something very dry. I think hair is okay as long as the hair is not oily, or something rough like my trench here. Yes, when you rub this ruler, it's going, and you bring it near these pieces of paper, this ruler is going to what? To pick these pieces of paper. Yeah, this is not magic, it's science. Yeah, so when you rub this ruler, what we do, we create charges. This ruler, before charging it, that is rubbing it, it has both positive and the negative charges. Now, after rubbing it, it will either become positively charged or negatively charged. Then that opposite charges are going to attract the opposite charges on the pieces of paper. So let's assume this ruler, after rubbing it, it becomes positively charged. So rub the ruler, maybe against your hair or sleeve, something like sleeve of cloth. Then the ruler will pick the small pieces of paper. Yeah, so reason, explanation here. Explanation. Yeah, so what is happening here? Rubbing the ruler will make the ruler positively or negatively charged. So I'm going to start with, we assume after rubbing the ruler, after rubbing the ruler, it will become negatively charged. Negatively charged. So the negative charges on the ruler, will do what? Will attract. Will attract the positive charges on the piece of paper. Charges on the small pieces of paper. On the pieces of paper. Yes. So, and I told you before charging anything, it has the positive and the negative charges. Yes. So, remember I told you the different, opposite charges do what? Unlike charges attract, but like charges repel. Yes. So, that's our second experiment. The first one I told you. Now we're going to our third experiment, then the fourth experiment, then we'll be done with the experiments. Yes. So the second experiment we're going to look at, the third experiment here, we're going to, we still are charging by friction. Now here, we're going to use balloons. We're going to use balloons. Of course, it's still charging by friction. Charging by friction. And remember, we're using materials which are not good conductors. Yes. So what in this experiment we're going to use a balloon. So we have a wall here. This is a wall. So this one is A. This is a wall. We have a balloon here. We have a balloon here. This wall has both positive and negative charges. It has both positive and negative charges. And now we charge this balloon. This is A. Let me draw B. This one is A, illustration A. This one is B, where we still have our wall here. And now we bring what? We bring the balloon which was charged, and it's going to stick. It's gonna stick on the wall. Okay, let me redraw it. Yeah, so we have our ruler here, our wall here. This balloon is going to stick on the wall, and you're going to realize here we have positive charges near the wall, and we have negative charges further away. So look at these two experiments. We have our balloon here. The first thing we do here, we rub the balloon. When we rub the balloon against any dry substance here, we're going what? We're going to charge this ruler. Now, before we rub the balloon, it has both negative and positive charges. So, we rub the balloon. The balloon becomes negatively charged, according to what I've drawn here. The balloon becomes negatively charged. The balloon becomes negatively charged. So, after the balloon becomes negatively charged, we bring the balloon closer to the wall. We do what? We bring the balloon next to the wall. Then what is going to happen? It will stick. The balloon will do what? Will stick. The balloon will stick. Will stick on the wall. Yes, so what's happening here? This balloon becomes negatively charged. And when you bring it closer to the wall, remember this wall is both positive and negatively, has both positive and negative charges. So what is going to happen here? The negative charges on the wall, these negative charges on the wall are going to attract all the positive charges, and it's going to stick. After sticking on the wall, all the negative charges are going to do what? To repel away from the wall. So that's what I'm insisting. Unlike charges attract. Yeah, so here, the negative charges on the balloon, the negative charges on the balloon will attract the positive charges. Will attract all the positive charges on the wall, and it will stick on the wall, and it will stick on the wall. And what about the negative charges? The negative charges on the balloon are going to repel. So the negative charges on the wall are going to repel and move away from the wall. So the negative charges on the wall, the negative charges on the wall, will repel and move away from the wall. Yeah, so that's what's happening here. Just in case you're being drawn such kind of an illustration in exam, make sure you can interpret it well, and you secure your around 3 marks or 4 marks, depending on the examiner's idea. Yes, so the next experiment, I think it will be the last. Yeah, the last experiment we're going to look here, it's about we're going to look at the, what is this one? Yeah, electroscope. We're going to look at the electroscope. Yes. Yeah, so we're going to look at how do these charges behave in an electroscope. Yeah, so electroscope here, I'm going to sketch it. Of course, an electroscope has a metal rod. It has a metal rod. Okay, I'll sketch it fully. It has a metal rod here, up here. Then this metal rod is connected down here. Yeah. I'll try to make it as decent as possible. Then we have a metal plate, a metal rod, and this metal rod has a leaf. So this one is a metal plate. A metal plate. Okay, this one is about electroscope. Yeah, so it has a metal plate. Then we have a metal rod here. A metal rod, and we have a leaf here, electrostatic leaf. Yes, so we're going to make different observations depending whether the substance we're going to bring next to the metal plate is positively or negatively charged. So we're going to use a rod here. We're going to use a positively charged rod and a negatively charged rod. Whatever observation we're going to make here, we're only going to make observation on the leaf. What will be the behavior of this leaf? Yeah, so the first experiment we're going to do here, the first one, here, we're going to use a positively charged. Okay, now, before I proceed, this electroscope has both positive, it has both positive and negative what? And negative charges. It has both positive and negative charges. So before we bring any charged rod, yeah. So the first one we're going to look at here is our part A. We're going to use to bring close a positively charged rod. Look at this. This is a positively charged rod. This rod is positively charged. Yeah, so I'm only going to sketch the middle parts. Okay, let me try and sketch a better one. Yes. Okay, so we have our electroscope here. Of course, it has a leaf here. Yes. So we're bringing a positively charged. So this one is using a positively charged, a positively charged what? Charged rod. Yeah. Yeah, so using a positively charged rod. Using a positively charged rod. Yeah, so look here. So we're going to bring a positively charged rod close to this metal plate and see the behavior of our leaf. So what's going to happen here? When you bring the positively charged rod closer to the metal plate, what is going to happen here? These positive charges are going to repel. They're going to repel with all the positive charges, and these positive charges will move down to the metal rod. Yeah, so all the positive charges are going to repel and they'll move down to the metal rod and to the leaf, and both the leaf and the rod are going to obtain same charges, and at the end of the day, what is going to happen? Repulsion is going to happen. And how are we going to illustrate this repulsion? This repulsion is going to be shown by this deflection. You know, this leaf is going to move away. You know, attraction and repulsion. When you're attracted to something, you feel like a spark. You've ever used You've ever used a magnet. Yeah, you feel kind of some force which is trying to pull you. But now for repulsion, you feel like some force is trying to what? To push you away. Yeah. So the observation which are going to be made here, observation here. So we'll have the negative charges are going to do what? They're going to attract to the positive metal rod, and all the positive charges are going to repel. And all the positive charges are going to repel and will move down the metal rod and the leaf. Now what is going to happen here? This leaf will deflect. So observation, observation. So what I mean by saying deflection, I mean it will rise. So this leaf is going to rise. So the leaf will rise. Let me use a simple English. So the leaf will do what? Will rise. Or will do what? Will deflect. Will deflect. Yeah, so this leaf is going to deflect. And now the reason why it's going to deflect, the positive charges are going to repel to all the positive charges on the metal rod, and they will move downward to the metal rod and the leaf. And now the leaf and the metal rod are going to repel and the leaf will rise. Yeah, so here explanation. Explanation here is the positive charges on the rod, on the rod will repel with positive charges, we repel with the positive charges on the metal plate, and they will do what? They will move down to the metal rod and leaf. Repulsion is going to take place between the leaf. So here repulsion will take place. Repulsion will take place between the rod, between the metal rod and leaf, and the leaf will do what? And the leaf will rise between the leaf and the metal rod, and the leaf will rise. Yes, so that is the complete explanation. It's a very simple one, so make sure you can at least memorize it. Yes, so we're going now to use a negatively charged rod. We're going to bring this negatively charged rod closer to the what? To the metal plate. So onto our, I think this is the last bit of it. Yes, so the second part, B here, we're going to use a negatively charged rod here. We have a negatively charged rod here. This negatively charged rod we're going to use a negatively charged rod. This rod is going to be brought closer to our uncharged electroscope. You're going to bring it closer here. Yes, so these what is going to happen? The negative charges are going to repel. The negative charges are going to, they are going to attract all the positive charges. And all the negative charges are going to do what? Are going to be repelled and they are going to be pushed downwards. The same observation, the same explanation takes place here. This negatively charged rod is going to attract to all the positive charges here and repel to the negative charges, and they're going to move down to the metal rod and the leaf, and the repulsion will take place and the leaf will do what? Will rise. The same explanation. So here we were using what? Using a negatively charged rod. So what is going to happen here? The same explanation. So what is going to happen here? The negative charges on the rod repel with the negative charges on the metal plate, and they will move, and they will move downwards to the what? To the metal rod and leaf. So repulsion will take place. Between the leaf and metal rod, and the what? The leaf will rise. Yeah, you realize it's the same explanation. Yes. So once you just grasp some idea, you're going to realize that all this will flow. Yes. So the last thing I want us to look at, this is the very last thing I want to look at, is that we have the dangers. What are the dangers of static electricity? The dangers of this static electricity. The reason why I'm starting with the dangers and I don't want to go first to the applications is because the applications need more explanation, which we won't cover for the remaining minutes. So the dangers of this static electricity, I'm going to mention around only two. The ones we experience in our real life experience, day in, day out activities. So I'm only going to mention two. When you get out of a vehicle after sitting for a very long journey of around maybe 7 hours and so, you realize that when you go out of the vehicle, when you just step down on the ground, you feel like there's some shocks you feel on your shoes and under your feet. You feel like you received some kind of shocks which you can't explain. I know you have experienced that, but the thing is you didn't realize. But now go and be keen. When you have sat down for a long time, maybe traveling, maybe in a lecture hall and everything, you're going to realize that when you stand, you're going to feel some electric shocks under your feet. That is one. So after sitting down for long hours, when you stand, you will feel some shocks, small shocks, electric shocks under your feet. under your feet. That is, it might not be that dangerous, but no, that is danger. You might even start overthinking that you are sick and everything. Yeah, so this is one danger. And another one, when you are taking off a very tight cloth, and most of the time they are made of materials which are somehow nylon, like cotton, some of the kind of materials. Yeah. So when you are taking off a cloth which is very tight, you'll feel like you're feeling some heat. I don't know whether you can go and experience, experiment this. Take your tight cloth, which maybe you have overdone it, and try to put it off. You'll feel like there's some heat, some shocks. You'll feel some shocks on the skin, and all of a sudden you'll be feeling a lot of heat. That is creation of what? Electricity. This static electricity. It might be dangerous because it can even cause panic. You'll even start panicking, like, what is happening to me? You feel like it's being difficult to even breathe because you're already overthinking. Yes, so when you take off a very tight cloth, when you take off a very tight cloth, you'll do what? You'll feel some shocks. They're harmless. We feel some shocks. Yeah, you'll just feel some shocks. And of course, there's some rise of temperatures. Yes. Yeah, so I said under the application, the advantages of this static electricity, just to mention three, which may require some explanation. We have photocopying machines. They use this static electricity. You also have the printers, inkjet printers. We also have the electrostatic painting. The painting. Yeah, you look at the bicycle. When you look at the bicycle, the wheels of the bicycle, they are painted, and they're like someone took a painting brush and they used the whole day to paint one grill by one. No, this is because of what? That electropainting and the use of static electricity. So for today, I don't want to go much. This is the end of this topic. Yeah, so the next topic is under waves, and I will tell you when we continue from there next time. Yeah, so for today, this is all. Make sure you can explain the experiments. Make sure at least you understand the concept from the introduction is very key in this one. So as I told you earlier, this topic is very short. It's very short. Yeah, so next time I'm going to come with some around 2 to 3 questions which we will answer, and before we continue to another topic. So for today, I've been your teacher, Madam Naomi, and I think we'll end there. Thank you so much, and have a nice time. Ooh.